2 minutes.
Okay.
Done.
Okay. So good morning, all of you.
Good
Good morning, ma'am.
morning, ma'am.
Good morning, ma'am.
Fine. So fractional distillation we have finished yesterday. Uh, this is a part of revision. Again, we are doing it in the next slide. So please, one of you take up reading better. Acha, what you must have got this what you got as the thought in your group. Did you go through the thought in the group, Vita? Hello, hello.
Yes, ma'am.
Yes. Did you go through the thought which is given in the group?
Yes, ma'am.
What is it? What is it, Vita? What is written in the thought? What is written in the thought, Vita?
Investment in a knowledge pay the best investment.
Yeah. So knowledge is the best investment. In short, right? Knowledge is the best investment, right? Before we continue with this, should we start our day with a prayer, Vita? Should we start our day with a prayer? Hello, hello. Am I audible?
Yes, ma'am.
Yeah. Start the prayer, Vita. Start with the prayer. One of you
أعوذ
take up.
بالله
Thank you.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين.
Thank you, Vita. Now, the thought. What do you understand by this thought, Vita? Knowledge is the best investment. That's what I feel. What do you say? Do you agree with it? You agree with it? What is knowledge, by the way? Knowledge is attaining new things. You are growing every day. You are developing yourself in a beautiful manner. You know so much. Your way of thinking changes. You see from others' perspective that nothing is right and nothing is wrong. You understand why the other person is behaving that way. So we don't get angry. We understand, rather, we try to understand everybody's problem. That is knowledge. How you see things, that is knowledge. How you get things, that is knowledge. How much you take inside yourself, that is knowledge. And how much you execute, how much you give it back, that is knowledge. Is it understandable to all of you? So
Yes,
whenever we say, oh, there's no exam, we studied so much, it's a waste. It's never a waste. Nothing goes waste, better. It will come back to you some way or the other. That's why I keep on asking you, keep reading, take informations as much as possible because life is short. You understand?
yes,
And
ma'am.
be knowledgeable because when you are knowledgeable, you become wise. You get wisdom. and you become better every day. And the society becomes great because it's not only you. Your friends are also becoming better, isn't it? So you have to part with your knowledge to others also. You have to share your knowledge with others as well. It's not that only gaining knowledge is enough. No, you should share it with. You should ask others also to invest in knowledge. You understand?
Yes, ma'am.
Okay, fine. So I think I've tried to make you understand what exactly is to this thought conveys the message as. I wish that you will at least understand this thought and work according, at least for today. Ninth standard, am I clear?
Yes.
Yes, okay. Let's start with now fractional distillation. Start better.
Fraction distillation. It is a process to separate two miscible substances from each other by heating them at their boiling point, followed by condensation. Through fractional distillation, we can separate two substances having difference between their boiling points less than 25 Kelvin. For example, refining of
Petroleum. What you will say, beta? Yes, very
petroleum
good. See, can
refining.
you see this? Petroleum,
Yes,
petroleum, raw material. This is refining of petroleum. Now, this fractional distillation I taught you in 8th standard. Hope you remember. Petroleum products. Do you remember? Fractional distillation, refineries, petroleum refineries. Remember? Boys, I'm asking you. Can you hear me?
Yes.
yes,
Yes. Did we learn something about this fractional distillation in class 8? Do you remember or not? We talked about petroleum refineries and the byproducts of distillation as petrol, kerosene, diesel, grease, paraffin wax. Remember?
yes, ma'am.
Yes. So we had already done it. Now we are going to do it in detail. So what we do actually, we are separating more than two miscible substances from each other by heating them. At what? At their boiling points. And then we condense it. You should be very careful that the substances should have a difference less than 25 Kelvin. That is a must. Then only fractional distillation will work. Here we are refining petroleum products. Can you see over here? So this is petroleum gases. First the gases comes out because it is lightest of all, followed by gasoline, then kerosene, then we have fuel oil that is used for aviation. Then we have lubricants that is called as grease, and then we have residue. Residue is unwanted, which is a waste that is at the bottom. Do you understand how it has been removed according to the boiling point? Okay, beta. Do you understand, boys?
Yes.
Now we are going to work on crystallization. We get pure solids by crystallization. Please start.
Purification of solids by crystallization. Crystallization is the process of obtaining a pure solid in the form of crystal from a solution. For example, by crystallization, we can obtain pure copper sulfate from its solution. Dissolved about 5 grams of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Evaporate the solution in a china dish to get a saturated solution. Cover the solution with a filter paper and allow it to cool. Pure copper sulfate crystals formed are formed.
Fine. This is how it looks like. See, this is impure copper sulfate powder. Here you can see this is
Yes,
copper
ma'am.
sulfate powder. Okay, this is impure. And can you see over here? Beautiful. This is pure copper sulfate crystals. Hope you understood why are we doing this crystallization? To get pure stuff.
Yes.
Beautiful. Isn't it? The crystals look beautiful. See, isn't it better? Look at this one and look at this one. See, can you make out the difference? Okay, fine. Now, this is a process when we obtain a pure solid. How does it look like? Crystals. When we make solution, out of the solution we make crystals. So we are getting pure substance from the solution. For that, what we have to do? We have to take 5 gram of copper sulfate powder, little amount of water we have to dissolve. Then you have to filter the solution so as to remove whatever impurities you can see that has to be removed by filtration. Then the solution you will put it in a china dish. Okay? And this solution you will cover with a filter paper. You understand? Then what you do, you are heating this china dish which has got this saturated solution of copper sulfate, and then later you will cover the solution with a filter paper and allow this filter paper to cool. So you remember those solution will stick to the filter paper, and later you can see the copper sulfate crystals sticking to the filter paper. You understand now? Hello? Do you understand?
Yes, ma'am.
Yes, ma'am.
Yes. Same thing again.
It is a process of separation by making pure crystals of a substance from its supersaturated solution. Example, crystal of copper sulfate CuSO4.
Very good. Now Cu should be written like this. CuSO4, right? This is the formula. But when you
Yes.
type it, it is difficult, so it's been written like that. Otherwise, it is C capital, U small, S capital, O capital, and 4 in the subscript. Okay? This is how it is written, copper sulfate. Here you can see. You see this? Over here you can see copper. This is another way of getting the crystals. The other way what we saw was putting the filter paper on the solution and allow it to dry, and we get the crystals. Here you have to heat the copper sulfate solution to get the pure copper sulfate crystals in the test tube. So there are two ways to find out or to obtain pure copper sulfate crystals. Understood all of you?
Yes.
Only I'm getting Moinuddin your answer. What about rest of you better? If I say ninth
Yes,
standard, that
ma'am.
means all of you should say yes. Okay? I'm not teaching ones and twos better. Now the next one is electrolysis. What is this? Electro
Yes.
means electricity, isn't it? What is the electro means beta? Electricity. Okay? And lysis means breaks. What is lysis means? Breaks. So what we are doing, we are taking the help of electricity to break. Let's see what is breaking. Start.
Electrolysis. It is a process of separation with the help of electricity. Through electrolysis, we can separate compounds. Also, in this process, direct current DC is passed through the substance.
Now you understood what are we doing? We are passing the electricity to separate certain substances, right? Yes? Boys,
Yes, ma'am.
yes? Did you
Yes.
understand what are we doing? We are taking a solution and we are passing electricity through the solution to separate certain substances. That is called as electrolysis. Okay? This is how it looks like. You understand? Making a circuit.
Yes.
See? This is how, see, a circuit is made. You see this over here? A circuit is made. Now, how to separate components of air by fraction distillation? Start.
Separation of components of air. Air is a mixture of gases. The components of air can be separated by fractional distillation. Air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separate at different heights depending on their different boiling point.
Fine. We know air is a mixture of gases, Peter.
Yes.
Yes, and these gases can be separated by fraction distillation. What we do first? Air is compressed, like how we do LPG. What we do in LPG, we compress with allowing the pressure to be on the gas and we fill it in the cylinder in the form of liquid. That's what is called liquefied petroleum gas. Do you understand? Do you understand? Same way, air is compressed by giving lots of pressure and then it is cooled. The temperature is decreased, so we get liquid air. What we get, beta? Liquid air. Now this
Record.
liquid air is warmed up slowly, where in a fraction distillation column. Then the different gases will separate at different heights according to their boiling points. I hope the things are clear now. Is
Yes.
it clear now? This is air. Let's do one by one. Air. What we do? We compress the air and then we cool by increasing the pressure and decreasing the temperature. So what we get? Liquid air. Is this agreeable? Is this is what we have read just now? Hello?
Yes.
Yes? Okay. So we get liquid air by increasing the pressure and decreasing temperature. Then this liquid air is warmed up. Yeah? Warming up.
Warmed.
Where? In fraction distillation column. You agree? Nice standard?
Yes. Yes.
Then what happens? Gases get separated at different heights according to boiling point. Is it clear? Is it
Yes.
clear?
Yes.
Now, what do you mean by physical change? What do you mean by physical change? Let's see.
Physical change. The change in which only transformation of state is happened. No new substance is made are called physical change. These changes are reversible. Example melting of ice.
Physical change means physically it changes. What is the meaning of physical state of matter? Solid, liquid, and gases, right?
Yes.
Yes. So state transformation, that is solid will change to liquid or maybe to gases, that is called as physical change. But water remains water. For example, ice, liquid, say water and water vapor. There's a three states of water, right beta? But it remains water. Water vapor is also a form of water, ice is also a form of water, and water is also a form of water. You agree? There is no new substance. Water
Good.
remains water, whether it is ice, whether it is liquid or water, or whether it is water vapor. It remains water. So there is no new substance which are formed. And these changes are reversible. That means the ice can become water, water can become ice, water can become water vapor can become water. Right? So these changes are reversible. For example, melting of ice. Can you see this melting of ice, beta?
Yes.
You see this? Okay,
Yes,
it is
ma'am.
melting. It is melting, so it is become a liquid. But when I put it in a fridge back, the liquid will become ice again. Am I right? So these are reversible. So how we show the reversible? Remember, this is the way we show it is reversible in the equation form. Right, beta? So I can say ice And what I will write over here, beta? Water. Right, beta? And
Yes,
this is
ma'am.
the arrow. This is the reversible arrow. Now, if I put only one arrow, for example, this much, only one arrow, that means it is irreversible. It's going on your this side. It will not come back. Whereas this arrow is reversible. Is it clear? Is it clear, beta? Hello.
Yes.
Clear? Now we come to chemical change. Say,
Chemical change. It is a change in which a new substance is made. In this change, the chemical properties of the substance change. These changes are irreversible. Example, cooking of food.
very good. Thank you. Now, chemical change means what? A new substance is formed. I repeat, a new substance is formed. Okay? The chemical properties absolutely changes. For example, egg, you are cooking egg, right? See, when you make an omelette or you make a bhurji, it changes. When it is raw, it tastes different, but when you cook, the taste is different. So a new substance is formed. Hope you understood. Hello.
Yes.
For example, mama
Yes.
cooking vegetables, right? Say, mama cooking vegetables, isn't it? How it tastes when it is raw,
Yes.
when it is cooked, it tastes different. So a new substance is formed. So that is
Yes,
called
ma'am.
a chemical change. What it is called? Chemical change. Is it clear?
Yes.
All of you understood better?
Yes, ma'am.
All of you understood good. So we
Yes,
come
ma'am.
to, yes, but we come to the close of this chapter. Now I want to ask you, I still have got 15 minutes. Now first question is, have you understood whatever has been taught to you? Boys, have you understood whatever has been taught to you? I will be revising it. In 10 minutes, I will be revising. Just 5 minutes, I want to talk to you. And 10 minutes, I am going to give you the complete summary of what we have learned so far. Yeah, now my question to all of you is, whatever I taught you, did you understand?
Yes.
You, Moinuddin, you understood. What about rest of you?
Yes, ma'am.
You have understood. What about others? Nakvi, Aliasgar, what about others? I cannot name you. I cannot ask you personally. Is clear? Boys, it should be commonly the common answer, yes, we have
Yes.
understood. Okay. So I just want to wind up matter. Please pay attention to all of you. So what is the important, what is the topic all about? It is matter. You agree? You agree or
Yes,
not?
ma'am.
So matter is
Yes,
divided
agree.
into two substances. Two,
Substance.
yes. One is pure substances and the other one is impure substances. Agree? If you don't, then
Yes.
stop me. So, what is that? First one is pure substances, and the second one is impure substances, right? For example,
Yes.
I write matter. Okay? So, matter is divided into pure and then impure, right, beta? Now, impure also means
Okay.
it is a combination of other substances, so it can be called mixture also. Can we call it as mixture? Impure substance can be called as mixture. Hello? Hello? Can you hear me, beta?
Yes, ma'am.
Yes,
Yes,
impure
ma'am.
substances can also be called as mixture.
Yes.
Yes, fine. Now we come to pure substances. Pure substance. The pure substance is further classified into elements, right, beta? And compounds. Agree? That is pure substances.
Yes.
What do you say? All of you agree or not?
Yes.
Whereas
Yes, ma'am.
elements cannot be broken down. Elements cannot be broken down, but compounds can be broken down into elements. Yes or no? Because compound is made up of elements. All of you agree?
Yes, ma'am.
Yes? Okay. Now we come to impure substances, that is called as mixtures. Now mixtures is further classified as which type of mixture, beta? Homogeneous mixture, remember? And
Homogeneous mixture. Yes,
heterogeneous
ma'am.
mixture.
Heterogeneous
Understood, beta?
mixture.
Yes. What is
Yes,
homogeneous
ma'am.
mixture? I am
Understood.
giving the example as salt solution or sugar solution. That is uniform composition. And heterogeneous composition, I think you can say iron filings with sand. Yes or no? Then we can
Yes,
take
ma'am.
a soil, tablespoon of soil in water. That is non-uniform composition, right? Because you can see that in the glass, it will deposit, the heavy particles will deposit at the bottom. Some particles will be moving. That is a solution. So we can take it as a mixture also, example. And some will be floating. So it is non-uniform, right, beta? What is uniform? Uniform is this. It is equal everywhere. That is uniform. You got it? This is uniform.
Yes.
Understood? All of you understood, beta?
Yes, ma'am.
Now we
Yes,
come
ma'am.
to, okay, now we come to elements. Now we come to elements, right? Now elements are furthermore classified. I mean, you know elements are pure substances, right? So it is further classified as metals, metalloids, because it is in between. So I'm keeping it in between, and non-metals. Right, beta? You understood? So elements are further classified into metals, metalloids, and non-metals. What are metals? You know they're malleable, they're ductile, they're good conductors of heat and electricity. Agree? Example, copper, gold, iron. You agree or not?
Yes, ma'am.
Hello?
Agree.
Agree. Now what are metalloids? Metalloids have got properties of metals as well as non-metals. For example, they are silicon. Let's talk about non-metals. So what are non-metals? Whatever properties metals have, non-metals don't have. So they are non-malleable, they are not ductile, and they are bad conductors of heat and electricity. What is the answer? Example, oxygen. Is it clear? Is it clear, beta?
yes, ma'am.
Yes.
Now we come to compounds. So elements is over. Now we come to compounds. So far, is everything clear? Whatever I taught you so far, it's a summary of the chapter. Have you understood?
Yes,
Yes?
ma'am.
So, and the compounds are made up of elements. You agree? Compounds are made up of elements. Isn't it? Yes? And they can be separated by chemical processes. It is a homogeneous substance. Remember that. It looks the same. So, it is a homogeneous substance. And they are always having a fixed melting point. If they are solid, then they are having a fixed melting point. If they are liquid, then they have got a fixed boiling point. You understand? You understand, beta? For example, I'm saying compound as water, H2O. Now, hydrogen is what, beta? Gas. Oxygen is what? Gas. But what is water? It is liquid. Is it clear? Is it clear? So, the property of compound, what is the property of compound over here? Is liquid. It is different than the properties of the elements. What are the elements over here? Hydrogen, oxygen, they are gaseous. This is the features of the compound, that they are different than the elements, right? Boys, can you hear me? Hello? 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 Boys, can you hear me, beta? Hello? Hello? Can you hear me, beta? Virani? Can you hear me?
Yes.
Okay. There was no answer, so I had to go back to check whether the recording is on or not. Fine. Now we come to mixtures. What are mixtures? They are either made up of elements or compounds, and they have no ratio as such. They can mix with any ratio. So it could be homogeneous or it could be heterogeneous. But over here, for example, mixture is, I take salt, that is NaCl, right? And what I add iron filings, that is the nails. So now it is not mixing with each other. The properties of the constituents are retained. You understand? So here no new compounds are formed. And I can separate it by a simple physical process, and it could be magnetic process. I can take a magnet and can remove iron filings from salt. Am I right? Hello? Better you have to answer me, then only I will understand whether you know or not. Boys, can you hear me? Hello?
Yes, ma'am.
Yes? Okay. Now, how do we separate the mixtures? The separation method. Okay? First is the separating funnel. Where do we use the separating funnel, beta? When we are using two immiscible liquids. So, which one method that we are going to use? Separating funnel. What are we going to use, beta? Separating funnel. So, we use separating funnel for separating two immiscible liquids which are not mixing. Then we have sublimation. What is sublimation? When a substance directly changes, solid substance directly changes to gaseous. There we can use sublimation. For example, camphor plus salt. Right, beta? The camphor sublimes. Salt remains back. It does not sublime. So I
Yes,
can
ma'am.
separate it out. Then we have centrifugation. The butter from the buttermilk, remember beta? That's what we learned yesterday to make out cream. So centrifugation is what? Solid particles which are insoluble from buttermilk, that is liquid. So solid particles are separated from liquid. So butter is separated from buttermilk. Am I right, beta? So milk and cream are separated. That is centrifugation. Then we have distillation. Now distillation, we have done a simple distillation process and a fractional distillation process. Am I right? Distillation is simple distillation and the other one is fraction distillation process. Why are we using it? Where are we using it? When two miscible liquids, beta. Always remember that. Two miscible liquids. To separate two miscible liquids, we use distillation. Then we have chromatography. We are separating dyes. That this dye is made up of how many colors? So we separate colors from dyes by using chromatography. And also we have learned regarding electrolysis, which is the last one. It is not in your syllabus, but I have taught you better. Electrolysis is not in the syllabus. Electrolysis. So what are we doing? We are using electricity to separate the components of the solution. Is it clear? This is what you have learned. Then we have learned about physical change and chemical change. So what is physical change? Can you hear me better? Boys, can you hear me?
Yes, ma'am.
Okay. Are you understanding whatever I'm doing?
Yes, ma'am.
Okay. So physical change is what? First one is no new substance is formed. Right? Properties of the elements are retained. And it is reversible. What we learned beta? The ice cube becoming water when we heat it, and when we cool it, the water becomes ice. So it is reversible process. Have you understood this much? It is reversible. Have you understood this much better?
Yes, ma'am.
Now we come to chemical change. New substance is formed. Agree?
Yes, ma'am.
New substance is formed. Then the properties of the elements changes, and this is irreversible. Generally, I'm talking about it is irreversible. At very certain cases, it may be reversible, but generally it is irreversible. This is how you have to learn. It's clear? It's clear, beta? Then we can talk about the solution. What is solution made up of, beta? Solution is made up of solute plus solvent. Am I right, beta? Hello? Solute is
Yes,
less.
ma'am.
Yes. Solute is less and solvent is more. I hope you know that. And generally solvent we take it as water. Right, beta? Yes or no?
Yes, ma'am.
Yes, ma'am.
Now we will have types of solution. So solution types are, I will just take 1 minute, right? Solution types are aqueous solution, then we have non-aqueous solution, then we have true solution. Am I right, beta? Am I right? Hello? Then I can further divide it into, in the solution itself,
Ma'am, lecture is over.
I know that. Saturated solution and unsaturated solution. Is it clear? Is it clear, beta? I think I have tried to give the summary as much as possible that this is what we have learned in this chapter. And please go to the uploaded video for your revision purpose. It will help you a lot. Thank you.